Here we have yet another limit that involves trigonometric functions. And as usual, we always like to try substitution as a method for evaluating limits. I think you'll notice that if we put 0 in for h right away in this case, we'll end up with sine of pi over 3 minus sine over pi over 3, which is 0. And that h will turn into a 0. And so we get our usual indeterminate form. Before we talk about how we're going to evaluate this thing, I do want to point out that this particular limit has meaning beyond just practicing to evaluate limits. This is called the limit of a difference quotient, and it's going to have a big place in our studies as we move forward and take a look at what we call a derivative. For now, we're just trying to evaluate the limit, though. And to do it, we're going to need a trig identity, because splitting this limit into just two pieces and subtracting them isn't going to work for us. So I'm going to focus on the fact that this is a difference of two expressions that involve sine. And I'm going to take a look through our trig cheat sheet and see what I can find. So I looked through our trig cheat sheet, and there were a couple of identities that involve a difference of sine functions. But if you take a look at this one right here, it looks like it might get us where we want to go. Now keep in mind that this is the sine of alpha minus the sine of beta. And if we're going to use this, we need to know what we're going to identify as alpha. For us, alpha will be the first argument, which is pi over 3 plus h. And beta will be the second argument, which is just pi over 3. And we will use this substitution and this identity to rewrite the limit and see if we can evaluate it. So let's begin by actually using that identity to transform this limit. So we're still going to have the limit as h approaches 0. But remember, we're transforming that difference in the numerator to something else from our identity. It's going to be 2 times the cosine of our alpha, which is pi over 3 plus h, plus beta, which is pi over 3, divided by 2, times the sine of our alpha, pi over 3 plus h, minus beta, which is pi over 3, over 2, and then we still have our denominator of h. We haven't done anything interesting yet. Oh, let me add a 0 right there. We haven't done anything interesting yet. All we've done is transform the numerator using our identity and the fact that we're going to use alpha equal pi over 3 plus h and beta equal pi over 3. Okay, so the next thing we have to do is do some simplification. I should be able to squeeze that in on the bottom of this slide. We have the limit as h approaches 0 of 2 times the cosine of, let's write this in, oh goodness, how come my pen is not writing? 2 pi over 3 plus h over 2 . Sorry, I'm not talking right now. I know my voice is annoying anyway, but there we go. And then over here we just have sine of, the pi over 3's are going to subtract to 0, so we end up with h over 2 right here. Okay, now we're in great shape. But let me move to a clean slide so we can finish this thing off. So here's that expression again, and we are about ready to finish this one off. Basically, we can break this into two pieces. We have 2 times the limit as h approaches 0 of cosine 2 pi over 3 plus h over 2 times the limit that should say limit. There we go. Limit as h approaches 0 of sine of h over 2 over h. Let's deal with this right-hand expression first. We're almost where we need to be. We have sine of h over 2. We really need to have an h over 2 in the denominator, meaning we multiply by a half. So I have to multiply by a half out here also. And then we know this limit evaluates to 1. So there's a 1 there. I can do substitution on the first piece of the first limit here. Put a 0 in, and I end up with the cosine of pi over 3. Cosine of pi over 3 is 1/2. And so here's what we end up with. 2 times 1/2 times 1/2 times 1. And all of that simplifies to 1/2. So the value of the limit is 1/2. Let's go ahead and check that on the graph and just make sure the graph agrees with our calculation. So here's our graph. I used the Desmos graphing calculator to display this. And first of all, just keep in mind that the variable we are interested in was h in the problem, but to make it show up on here, I just replaced that with an x. Now, we are interested at what happens when h approaches 0. So remember, x is our h, so this is the h-axis, if you will. And we're going to zero in on when h is 0. Well, when h is 0, take a look at it. It's going to 0.5 from the right-hand side and the left-hand side, just like our finger trick there. And so I think this graph supports the fact that the limit is 1/2. Well, good luck with the rest of your problems. Keep up the good work. Don't forget you can use these graphs to support your work and get an idea of where that limit's going. Take care.